as an editor for several high-impact journals, including Pharmaceutical Science Asia and PLOS ONE. And today's topic, do you ever have before for the antimicrobial resistance? Maybe some of you is new, and maybe on the master degree students, maybe it's the topic that also uh, could represent for the topic for uh, the pharmacist. Okay, so today's topic is about the antimicrobial resistance, and you can also prepare for your questions if you have any idea or questions in your mind while she presenting her lecture. Just keep it, and after uh, her presentation we will open for the QE session. Okay, so uh, let's begin with her presentation. Okay, Dr. Malika, the floor is yours.
Um, Good morning, everyone. Yeah, um, I have to say that it's my pleasure to give lecture to you today. And my topic today is about AMR. You heard about AMR before, right? And before I get to my slide, I'd like to ask you this question first. Thing that could be the biggest driver of AMR in your country. Okay, I have multiple choices for you. The first one is limited public awareness and education. Okay. The second one is uh, misuse of antibiotics in livestock and agriculture. Third one is availability of antibiotic without prescription. And the last one is overuse of antibiotic in human medicine. So please put your answer here. I have to say that there is no right or wrong. I would like to know your opinion. Okay. Now, limited public awareness and education get highest now. What else? The overuse of antibiotic in human medicine. Sometimes you catch just a cold and you get antibiotics. Okay. So it's kind of overuse of antibiotic in human medicine. Oh, there's some available of antibiotic without prescription. Okay. I'm still waiting until I get 42 people here. Okay. We're getting more because I have to say that if I ask this question in different country, I will get different answer. Okay. Some might say that, oh, all choices are the biggest driven cause of AMR, right? Not just only overuse in human, but misuse in animal in agriculture, also the possibility to drive AMR. And as you said, if you don't have education or you don't have awareness, it would be uh more factor that drive AMR. your country. So I would say, if I'm from Thailand, right? I'm from Thailand. The antibiotic I can buy it in a drugstore. Okay. Most of antibiotic we don't have prescription for it. We can go to drugstore or sore throat, and I can easily get antibiotic. If in that case, I would choose the third answer. I would say that the availability of antibiotic without prescription would be problem in Thailand. But if I go to Vietnam, they might say, oh, because we use a lot of antibiotic for animal feed, animal farm. Each country has different problem, right? And different cause that prevent AMR. So that's why we have to learn today, right? So let's go to the slide here. Uh, After this class, I think you will have education and awareness on AMR, especially on this topic that I will say today. The first one, I would talk about the current situation of AMR all over the world, okay, and also the resistant mechanisms, and also resistant microbe on spotlight. And one, how can we fight for the AMR in the future? Okay, what can we do as the pharmacist? So I think we all agree that the first question that I asked you, those are the factors that drive AMR. Misuse, overuse of antibiotic, lack of knowledge, they are the cause of AMR nowadays. And one said that if we don't get COVID-19 in 2019, AMR would be maybe hot top in healthcare system. Okay, do you agree with that? Because of the COVID, everyone worry about vaccine, worry about virus. So MI just dropped down from the panel. But if you think about, if we don't have COVID, I think MI would be um, the first thing that people in healthcare system talk about. Okay, go back. I love this slide because uh, he's the one who found penicillin, right? He's Sir Alexander Fleming. Okay. Everyone used to joke about his discovery because you know the story about his fight. He went for vacation. Okay. And he just don't clean everything up and don't clean his petri dish or don't clean his medium. But then when he got back, he found some fungi. Around the fungi got clear zone. Okay. And then he identified that fungi and purified the compound, the penicillin later. Okay. So that would be a big joke about his finding. He's the luckiest man got Nobel Prize, right? Find penicillin by accident. But before penicillin, if you think about maybe in 1910, we have to take arsenic compound, which is toxic, right? Everyone knows it's toxic, but we don't have anything to treat the disease. We have to use arsenic compound called salvarsan, okay? And later on, they make the derivative of arsenic acid. We have to take that compound to treat syphilis in the old day. But later on, after Sir Alexander Fleming found penicillin, we got so many antibiotics, right? We got what else? Penicillin, cephalosporin, carbapenem, Those kind of drug group start from penicillin. And if you look to the timeline, okay, the upper part here, the upper part here is the drug and the year that we discover it. Okay, from salvarsan to penicillin to sulfonamide, and later on, so many drugs. Okay, and below here, you can see we found the mic start to get resistant from the drug. Okay, you can calculate how many years that they will or they mutate to get resistant. Actually, it's very fast. Okay, compared to when you first discover penicillin, I think 1920 something. Okay, and after that, actually, it's Alexander Fleming student purified penicillin, and we use it in 1940 around that time. Okay, so we take some time to develop new drug, while the bacteria just mutate and become resistant microbe easily, maybe a bit faster than our development. And if you familiar with the resistant bacteria here, okay, the first case of penicillin resistant is Staphylococcus aureus, right? The gram-negative bacteria. And then when we have another drug to replace penicillin, we use methicillin instead. We got MRSA, which is the methicillin-resistant Staphylococcus here. Okay. And then we try to use vancomycin to treat MRSA. Later on, what we got? We got vancomycin resistant bacteria. So that's how bacteria develop itself or evolve, getting evolution to survive. Okay. So nowadays we got so many drugs in carbapenem group, right? Here. And carbapenem resistant is came out. Okay, you can imagine what will happen in the future. This paper is very classic. It's published in Lancet, and after published it, all over the world aware of the AMR problem. Okay, in this paper published that in 2019, there's 2.95 million deaths caused by AMR itself, just only AMR. Okay, from this number, they were doing some math, okay, and calculate that in 2050, people will die from AMR, 10 million patients per year, okay, which is more than cancer, more than other diabetes or other causes. So this paper in Lancet may urge the awareness of the public health worldwide. Okay. So after that, we got Superbug. Okay. I think you would be familiar with some of this. Okay. The first group of Superbug we call S. Okay. S stand for each letter stand for each bacteria. First E stand for Enterococcus faecium, S Staphylococcus aureus, K Klebsiella, T Pseudomonas, and E Baker. Okay, so the first group of superbug which highly resistant to antibiotic came out, and we call escape. On with our other group of bacteria like CRE, carbapenem resistant Enterobacteriaceae. Okay, and we found some other bacteria. In another group, we found that mostly it's related to hospital, right? We call it hospital acquired or healthcare associated infection. Okay, which means that patient who stay long in hospital, think high chance to get infected by these superbugs. Okay. So for the superbugs, we know about escape and other bacteria, right? But nowadays we have so many definition. Sometimes you heard about MDR, XDR, TDR. Of course, they all resistant bacteria. But how can people classify it, right? For MDR, just easy definition that the bacteria must resistant to at least one drug in at one group of drug that used to treat that bacteria, which means that if you have 5 group of drug that you use to treat pseudomonas infection, if the bacteria resistant to at least one drug in 3 groups, you call that bacteria a MDR, right? But for XDR or extreme drug resistant, sometimes it's referred to extensively drug resistant. Uh, the bacteria must resistant to at least one drug in all group of drug that used to treat it. But there's still some left, maybe 2 or fewer group that used to treat it. Okay. So XDR is more serious MDR, right? Okay. And the worst one is PDR. Okay. Resistant to all drug in all groups. Okay. The bad one. And too bad that nowadays we found a lot of PDR in the hospital. Okay. So from now on, if anyone come to you and say MDR, PDR, XDR, you know what it means, right? Okay. And here's the escape group. I'd like to make just a little point here. We've been using the term escape for so long. It means 6 pathogen here. But if you're in the US, they said that oh, Klebsiella is not that big deal for us. In US, Clostridium difficile is much more big deal. Okay. So they changed the K letter to C letter and call escape pathogen. So they remove Klebsiella and replace it Clostridium instead in the US. So it depends. Sometimes escape has 2E, okay? Not E here. They have double E, okay? And at E. coli. Okay, so if you saw it, there's no right or wrong on that, but it just depends on what they mean. Okay. Here's the CDC category. Okay. CDC is the Center for Disease Control. As you can see in the movie, when the virus attacks, CDC just wear those little dress and go into the village and get rid of the virus. So it's the same CDC. CDC also classify the type of AMR pathogen into 3 categories. They call urgent, serious, concerning. Okay, and CDC is in Atlanta in the US. So they focus more on pathogen. And you can see the urgent threat is Clostridium. That's why they replace escape group and use C-level, right? Okay. But other is mostly is gram-negative bacteria for urgent and serious pathogen. Okay. There's some gram-positive here for concerning, which may be less serious 2 groups. Okay. CDC just in the US, but look at the whole world. Okay, we know that we have WHO, right? WHO also have the unit that classify AMR. Okay, this one is just published maybe last year, 2024, and they classify the pathogen into 3 groups: critical, high, and medium. Okay, let's look at the critical one. We have Acinetobacter here, must be carbapenem resistant, right? And Enterobacterales This one is a big order. Inside, there's family of Enterobacteriaceae like E. coli, Klebsiella. Okay. This group must resistant to carbapenem or third generation cephalosporin to be classified as critical pathogen group. So the rest mostly are gram negative, right? The positive here, maybe S. aureus, Streptococcus. Okay, but mostly gram negative bacteria. Here's the list that I talk about. Actually, WHO firstly classified it in 2017 and just update the list last year here. So the update list just depending on the population or the case in each region in the world. So they change it and keep just only two critical here. Acinetobacter baumannii carbapenem resistant and Enterobacterales third generation cephalosporin resistant and carbapenem resistant. So these just three of them. So now you have in mind what pathogen you should look for. But how about the resistant mechanism? If I ask how bacteria can become resistant pathogen, there would be three main ways here. Intrinsic resistance, acquired resistance, and adaptive resistance. Okay, we cannot do anything with intrinsic resistance because bacteria resistant at birth. We know that this bacteria resistant to imipenem, we don't use it. Okay, so we know this at there. For example, I would say streptomyces. There are bacteria that can produce so many antibiotics. So we know that streptomyces would respond to antibiotic that they produce. So it's the same thing. So these are the example of the intrinsic resistance. Then we have acquired resistance, okay, which again very important, which means that bacteria A will become resistant bacteria, any resistant gene that they receive from bacteria B. Okay, it's like exchange process. From one bacteria, the resistant gene just jump to another bacteria. Okay, you might say that, oh, one species should be limited, right? Like A. baumannii can transfer just only to A. baumannii, but no, not like that. We found that Enterococcus can transfer the resistant gene to Staphylococcus aureus. We found that already. And this case occur for the resistance to vancomycin. Okay, so it's very important one, acquired resistance here. And the last one, adaptive resistance. This is another one that we saw in the hospital. Okay, when patients get hospitalized for so long and they got antibiotic for so long, the pathogen is just they just mutate and evolve and become resistant to that drug. Okay, or think about you get sick, maybe sore throat. I don't know, may caused by virus, but you got antibiotic and you take it just a couple of days and it's gone. The symptoms gone. You just, oh, I don't want to take antibiotic anymore. And then later on, you got infection again, you get the antibiotic again. So this kind of thing can cause the adaptive resistance. Here's the vertical evolution, as I said, from one bacteria that's used to be non-resistant, right? But if you grow them in a certain condition, like you put antibiotic in maybe small concentration, it's called inhibitory concentration. The bacteria, some die, but some will live. And the live bacteria here can divide it themselves and become drug resistant. Okay. We call that vertical evolution. But if you get it from your friend here, okay, in this room, you might transfer into your friend. That's called horizontal evolution. Okay. Same generation. Okay. Same class, same generation. And the way you get resistant by horizontal evolution is by this mechanism, the common mechanism that you learn in biochemistry 101, right? The conjugation, transduction, and transformation. Okay. You get resistant gene transfer easily. So if you remember the target group form antibiotic, we used to talk about cell wall. We used to talk about protein synthesis, DNA synthesis, cell wall, maybe disrupt cell membrane. So are the target of the antibiotic. The bacteria also have the resistant method to get away with this target also. Okay. So I think we can say that there are four main ways that bacteria can become resistant to the drug. Okay, first is reduce drug permeability. The second one is enhance F. Okay, think about water pump at your hometown or at your home. You pump water out. The same thing happen here, but pump antibiotic out. Okay, and the third one is enzymatic modification. Okay, might be modified on the drug itself or on the target that the drug has to bind, and alteration at target site. Okay, so four main resistant way that we have to keep in mind. Let's see how it's happened here. The first one is reduce drug permeability. Okay, think about bacteria, put the drug have to enter the cell wall first, right? So on the cell wall, how the drug get into the bacteria? They have equipment called porine protein. Porine is maybe I would say multi-unit protein on the cell wall of the bacteria. Porine usually take small substance, small molecule into bacteria and transport them. For example, they transport sugar, they transport metabolite, and also antibiotic. Okay, we call porine here. If there is some change or some modification on this protein, that's one way to become resistant bacteria. Okay. Another way is some bacteria can build up the biofilm layer. Okay. Think about the slime layer that you found. Okay. These are like exopolysaccharide compound that form the layer all over the bacterial cell. So you can imagine that if you put antibiotic, it just not go directly to the cell wall, but it has to get into this sticky slime first. So that's another way that bacteria can evade uh the drug. Okay. An example of this bacteria that usually have maybe porine change, mutation of the porine, or even loss of porine. Okay. Like Neisseria gonorrhea, Enterobacter aerogenes here, and also Pseudomonas aeruginosa. Okay, they say that change in OPRD or outer membrane protein can cause resistance. Okay, that's one, the first pathway. The second pathway is the efflux pump. Okay, this pump located at the outer membrane of the bacteria So it depends. If it gram-positive bacteria, it would be peptidoglycan, right? But for gram-negative would be outer membrane of the bacteria. So the effort pump locate there, and effort pump just not only a single proteins. It usually combine so many unit of the protein together and form the pump. Okay, think about the pump here. And nowadays we have 6 type of drug effect pump. We have ABC pump, we have MFS, we have R&D, and many types. But in gram positive, we use our ABC and MFS family here. So the differences depend on the protein subunit combined together. But for gram negative, it's more complicated. We usually found R&D super family here. Think about the wall of the gram negative. You have the cytoplasm first, and then you have outer membrane layer. Okay, so R&D is quite complicated and full with different subunit protein here. The classic example of the effort pump is tetracycline. It's been found many years ago. Later on, they found quinolone effort pump. But the classic example is still tetracycline. In the normal condition, okay, this pump just they don't active. They just stay there. But in the presence of tetracycline, tetracycline will bind with the repressor protein, okay, and release the suppression here and turn on the PET here to be active. So tetracycline here will was pumped out by the TET here. Okay, so those are the example of tetracycline. And as I said, so far we have so many pump, quinolone pump ciprofloxacin out, norfloxacin out, levofloxacin out, and we found it in many resistant bacteria also. The mechanism would be enzymatic inactivation or modification. I would say this example would be the biggest group of resistant mechanism, okay, because it includes beta lactamase. And so far, we know that there are so many of beta lactamases in this world. So I would say this one is a big group. How to inactivate the drug here? It can go two ways to degrade the antibiotic directly. Think about beta lactamase that cut beta ring. Okay, so it means just totally degrade it. And another way is just put some chemical group on the structure of antibiotic. Okay, maybe add adenyl group, add acetyl group. So those can inactivate the action of antibiotics. Okay, but again, the biggest group still beta lactamases. Okay, sometimes they call penicillinase, cephalosporinase, and again, one type of beta lactamase is carbapenemase. Okay, and you know that carbapenem is one big group of drug that used to treat gram-negative infection nowadays. So betamase still big resistant group for those kind of antibiotic. And for tetracycline, you have some bacteria can have some enzyme that add acetyl group, phosphoryl group, and adenyl group to the tetracycline and make it inactive. So this is just one example. The same story go with aminoglycoside here. Okay. Some bacteria can add phosphate group, adenyl group to the drug and make it inactive. Okay. So here's the example of the third resistant mechanism. Production of beta lactamases, production of aminoglycoside inactivating enzyme, and streptogamine acetyltransferase. So this kind of modify the drug. Okay. While beta lactam just degrade the drug at the beta lactam structure. And the last one is alteration of target site. Okay. Alteration of the target site mean that you have to know what's the target. Okay. The target can be wall, the target can be protein synthesis. Okay. And for this one, the target is the DNA gyrase, which is the target of the quinolone drug group. Okay. So making mutation here would change the resistance level. Also, the same story with rifampicin resistant, the drug that we use for TB, right? Mutation at the RNA polymerase at RPOB gene can cause resistance to rifampicin. The same thing with enzyme like ERM methylase that add methyl group to macrolide, lymphosamide, and streptogamine. So it's the same story here. Or staphylococcus, they have alteration of protein binding site for the drug here. They use make A gene, make C gene to modify the binding site for the beta lactam drug here. Or what else? Resistant to vancomycin. Okay, resistant to vancomycin mostly occur for those VRE, VRSA, right? Bacteria can produce the enzyme that change the alanine, the binding site for the drug to the lactate, to the alanine delactate. This way, vancomycin cannot bind to the target, and we fail for the therapy here. Okay, and I have to say that too bad that one bacteria can have all four mechanisms. Okay, they can have alteration of the target site, can produce degradation enzyme, inactivation enzyme. They can have all the mechanism that I talk about, but maybe in different level. Okay, and if you think about the WHO list that I show you, the pathogen, the first group is Acinetobacter baumannii. It's classified in critical group by the WHO, right? That we have to look after for the resistant problem here. If you stay here, mean that all baumannii cannot harm you. But if you stay in hospital, in that environment, Acinetobacter can cause for the patient in the hospital, even though we call it opportunistic pathogen. Okay, opportunistic pathogen usually cause disease for the vulnerable group, right? Not for healthy people. But if think about if you stay long in the hospital, maybe using IV catheter or other thing that contaminate with A. baumannii, it can be serious. And if you talk about the drug that used to treat A. baumannii, I would say, oh, we have so many drug group here. Okay, aminoglycoside to tetracycline. Okay, the classification of A. baumannii, we also have MR, PDR, XDR also. The same meaning. Okay, so if it MDR, it would be receive at least one drug in at least 3 group here. Okay, you got the knowledge about the definition or so MDR, XDR, PDR, we found it all for A. baumannii. We even found one bacteria that none of these that would work. Okay, we found more and more PDR here for A. baumannii. And as I said, it might not be harmful to healthy person, but in specific condition or specific area. For example, if you look about the global prevalence of the AMR that become MDR, I would say it's about 4%. Okay, 40% globally. But if you look at the Middle East and in America, it's about 60% MDR. Okay. And in Europe, of course, some country, for example, Turkey, Greece, more than 90%. Okay. I leave Asia because you can think how many percent. Okay. In Asia, I would say my hotspot for Ebola eye resistant. And when it become MDR, we usually use carbapenem drug to treat it. And then, of course, you can guess later on we got crab here, carbapenem resistant Ebola. Okay, and we get more and more. I will show you one thing that happened in Thailand. Let's see this panel first. This one is maybe 20 years, 24-year panel. They collect the sample from all over Thailand and look at the resistance rate. You can see Acinetobacter is here. It starts from maybe 10-15% of resistance. Now it's become 70, almost 80% to imipenem, the drug that we usually use in the hospital to treat Ebola. So you can see how bacteria can grow and can jump from non-resistant to become resistant bacteria. Okay. And yeah, it's quite problem in Thailand because if you look at carbapenem resistant, not Pseudomonas, not E. coli, not Klebsiella, but Ebola go up high here. Significantly, you can tell. Okay. And as I said, in the old day, when it's MDR, Ebola, we use carbapenem. Carbapenem like imipenem, meropenem, doripenem. We use those drugs to treat it. But nowadays we found carbapenem resistant. So many isolate, 70% that we collect last time. And it costs economic burden, you can imagine. Okay. And how about the resistant mechanism of AWI or mechanism, right? We found all. Okay, we found all in this bacteria. We found beta-lactamase. They can produce beta-lactamase enzyme, especially the group with OXA type. This one, oxapenem here, oxacarbapenemase here, degrade carbapenem drug, the drug that I said we used to treat it. Okay, major pathway here. And more than that, they have change in PBP, penicillin binding protein, they got mutation, acquired mutation. And for other drug group like aminoglycoside, the resistance pathway is mostly is methylation as the ribosome binding site here. Okay, with this gene that, and we found that ARMA gene is the resistant gene and can be transferred on the plasmid. Okay, it can jump from one bacteria easily with the plasmid, not the chromosome. How about other pathway like changes in polarity? This one is the main resistant pathway for another group of drug like colistin. Nowadays, for carbapenem resistant Ebola, if patient got infected, we use colistin to treat it. But with this mechanism here, LPS change. Okay, change in LPS can cause colistin resistance. So with different gene variety of gene cassette here. Okay, we found change in LPS and caused the colistin resistance. Also, effect pump. A-bomb also have effect pump. Remember that the one that I said mostly is RND type for negative. And A-bomb have this cassette ADE ABC here, which is the cassette pump for effect. Okay, so just give you an example. The bacteria has its own virulent factor. Okay, it could be toxin, it could be biofilm, it could be other uh, mechanism. But again, we found some drug to treat it and they become resistant. Okay, with those four major pathway that I talked. So what else should we use for this kind of bacteria? Okay, maybe we have to find something new for this bacteria. Okay, and then I would like to go to this another gram negative bacteria. In WHO version 2017, Pseudomonas aeruginosa is on the critical list. Okay, but after the update version and WHO revised it, they decided to remove Pseudomonas aeruginosa from the critical list into the medium, so into the high one. Sorry. So even though it removed, but we found so many Pseudomonas aeruginosa resistant in our region. Okay, it might be still a problem with our region here in Asia. So and also opportunistic pathogen. It can cause disease all over the body. Okay, cause brain infection, can cause heart infection, wound infection, or urinary tract infection. Mostly is opportunistic pathogen. Okay, people usually get pseudomonas by stay in a hospital and then got sepsis from IV catheter contamination. Okay, so it's quite another problem in the hospital, I would say. Pseudomonas also have the mess, but different type. I just would like to show you that different bacteria can have different resistant mechanism. Okay, even though they produce beta-lactamase, but for Pseudomonas, it's not like Eibomyia. Eibomyia is mainly focused on oxa type here, class D beta-lactamase, but for Pseudomonas, mainly is metallo-beta-lactamase. Okay, another group of beta-lactamase here that involved, and too bad that in Pseudomonas, we found all classes of beta-lactamase. Okay, we found some, but some is rare. Okay, in rare case. And changing for the outer membrane is the mutation here, mostly caused by OPRD outer membrane mutation. It, it can pump out imipineme. Okay, this outer membrane is membrane that used to take imipineme. Okay, so you can imagine we cannot use imipineme for this kind of resistance. Okay, here's the effect pump. Of course, Pseudomonas has it all. Effect pump here that we talk, they have it. They have make A B O OPRM, make XY OPRM. Those are the main type. And also there are some additional type of resistant effect pump here. Okay. And for other small group of bacteria like uh, Enterobacterales, this one is the order, right? Composed of E. coli and Klebsiella. Uh, I would say that the resistant mechanism mainly just production of beta-lactamase. We call carbapenemase. Okay, we call carbapenemase here. Klebsiella pneumoniae carbapenemase, we call KPC or KPC gene. NDM gene is another type of carbapenemase that they produce. It's from New Delhi, metallo-beta-lactamase. And the third one is the OXA48 type, oxacelinase, which is another group. So we can say for Enterobacterales, mainly is resistant by production of beta-lactamase. Okay, with these three pathway, KPC, NDM, and OXA48. Okay, so how about gram positive? Okay, you will feel better with gram positive. The mechanism of resistance is easy, just straightforward. For example, S. aureus. Okay, S. aureus, you heard about MRSA, ORSA, VISA, VRSA, right? You heard about the resistance for this pathogen. The main resistance is here, acquisition of MEK-A resistant gene. Okay, acquisition of MEK-A resistant gene encode for penicillin binding protein site. So changing in the target for the beta-lactam drug would cause S. aureus to be resistant or resistant to vancomycin, VRSA, right? Think about the enzyme that I talk about. Vancomycin bind to peptidoglycan at dealanine. But if the bacteria produce some enzyme that can change the alanine to other amino acid, vancomycin cannot bind. Okay, just straightforward. They don't recognize the binding site. Okay, another gram positive or the similar thing, VRE. Okay, vancomycin resistant enterococcus. Mostly it's changing in vancomycin target, changing in vancomycin receptor. So that would be a very easy way to resistance. Okay, this one is the first question that I asked you. I combine some choices together. Okay, misuse and overuse of the antibiotic, lack of new antibiotics, and agricultural use that are the main factors that drive AMR problem in our society here. Okay, I cannot say which one is the most important factor. I think it needs to combine together to become the problem. And you might think that, oh, if the problem occur in hospital or in pharmacy shop, we can just easily take care of that. But it's not like that. This one is international problem. Okay. Think about international travel. Okay. You fly a lot, you move a lot, or even in the border. Okay. So you're lucky in a safe zone, you don't have border with other country. But in some country, okay, we have border that people can carry the resistant bacteria across the border or the contamination in the food. Okay, that's why we have very strict regulation for import or export the food from one country to another country. Okay, and another factor, so think environmental transmission. Okay, think about resistant bacteria in the soil, in the water. Okay, that would be another factor that drive the resistance here. And I don't have to say like the clinical implication, not just the treatment failure. Okay, you have to pay more. The government have to pay more, and sometimes you cannot do anything. You just let them dead because no more drug that use resistant bacteria. So it's very difficult situation. And how we can fight it in the future. Okay. Yes. Most of you answer this question, awareness and education, right?
Yeah.
Question I asked at first, most of you answer that, oh, we lack of awareness and education. Right. You're right. If we put more on the knowledge and people can see how important is the MMR problem in the future. I didn't show the data here. I found one paper that said that in the past 10 years, we rarely find new antibiotic. I think there's a couple of registered antibiotic that people nowadays. Okay. It's not because that we don't have anything new. It might be because that the budget also getting low. Okay. And besides the chemical compound, we might have to go to the nature, to the natural compound also. We can think of it many ways. So first, give education, then do the surveillance. Okay. That's why we have to keep the record. How many resistant bacteria in hospital? Okay. What kind of drug that they're resistant to? It would be great if you can track the genomic surveillance also. You can know the strain, whether it's spread from uh, one country to another country. Okay. In our study in the lab, we found, I would say, maybe new strain or new serotype that spread from China and Myanmar to Thailand. And we are watching out for this strain. I'm not sure if we have the same surveillance system in Indonesia, but I think it's a must. Okay. It's not just phenotype tracking that, oh, we have bacteria resistant to drug ABC. You have to track for genomic also. The- so you know the serotype and how epidemiology goes for that strain. Okay. And then infection and prevention. Okay. Some might say, "Oh, it's just good sanitation, good hygiene. We do it every day." No, but I saw some significant change during COVID. Okay. One thing that we found is during the COVID, okay, you remember that time, 2018, 2020, you wear mask everywhere, right? You wash your hand how many times a day? You put alcohol gel on your hands how many times a day? At that time, reduce the COVID. We found AMR rate also reduced at that, which means that implement the infection and prevention control is also effective, right? Okay. And this one optimize the antibiotic use. Okay. You might say that, oh, I'm a pharmacist. Please go tell the physician. I think there's the collaboration between here, pharmacists here. We need to work. Okay. So the question is, how can we cope with the resistance in the future? Okay. Let's at the global level. Okay. At the global level, we have one health policy. Okay. So please remember this policy is quite worldwide. One health policy is just easy. It's focus on the collaboration and implement policy or anything, any program that look at the AMR surveillance rate in each country. Okay. So this program is like monitoring the resistant bacteria in each country and report it. Okay, we call it One Health. It not just report the resistant rate in the hospital. One Health involved with human, animal, environment, three domain that can cause resistance, right? They said that for One Health policy, we have to work together and track the resistance rate, or maybe they call surveillance system set up for people, animal, and environment. Okay. So things about this big project is all over the world now. Okay. But if you look at here the approach, we have to address MR in human health. We have to reduce antibiotic use in animals and livestock, and also in environment. No pollution, no spread of drug resistance in environment. Okay, so those of One Health policy is the big project that work together by WHO globally. Okay, but when we look at the national level, okay, some of you might heard about this project, the Antimicrobial Stewardship Program, or AMS. We call AMS in short. This kind of program that we can set up nationally. Sometimes in hospital, maybe in one hospital, you can set AMS up with the healthcare team with of the that involve infection. Okay, the basic of the AMS is the approach to educate and support healthcare professional to follow evidence-based guideline for prescribing and administrating the antimicrobial. Okay, so think about that. Educate first and support rational use of antibiotic. Right dose, right people. Okay, so this kind of collaboration, you have to work together with uh, different type of healthcare professional. Okay, you have to work uh, from administration. Okay, they have to support you anyway with the budget or the program, the infrastructure, and then assign the leader. It could be physician, the infectious, uh, the ID doctor, or the pharmacist. Become the leader, and then you recruit other people that involved with the prescription of the drug. Okay, maybe the doctor, the nurse, the pharmacist together, work together. Okay, and monitor the reasonable use of the antibiotic. At the same time, you should set up this program to educate other people. Okay, do you think it can be done? Is it easy? Okay, I don't see any, not here. I see just, maybe not. Yes, in some country, really difficult. We are pharmacists. How can we talk to the physician? The physician should know more about the prescribed drug. Some might think about that. But if you can generate or set up this program and make collaboration with the doctor, the benefit would be to your patient, right? Okay. I heard that you are in second year, right? You're gonna be a pharmacist in how many years? Normally 3 years. And you 2 years. Anyone want to longer? No, of course not. One thing that I can think, oh, it can be easily done. Okay, you in the hospital, you have to check the prescription, right? Before you send the drug to the patient, you can check the dose. Is it the right dose for this drug? You can check the ADR. You can check the drug action. Okay, just one little thing that you can start by yourself. Okay, and then later on you recruit other, talk to people, and start to set up AMS program. I think those things can be done. Okay, I won't talk about this anymore. Yeah, and another thing that we now set up is the surveillance program. Of course, in Thailand, we have no program, but um, we have program that maybe collect the resistant bacteria from all over Thailand, from the north, south, east, west, and they have to report the resistance rate to the drug, to the central. As I said, we need genomic surveillance system also. So that's what's one thing that we've been working on with the genome surveillance. And for other approach, of course, if you can find new antibiotic, okay, it would be best. Again, it takes some time, more than 10 years, right, for one antibiotic to get launched. It takes some time. Other therapy, some can use the combination therapy of the commercial drug that we currently use. Okay, as you can see, many combinations nowadays. Okay, or you can find other technology like bacteriophage, immunotherapy, or even the method that can detect early detect the resistant drug or resistant gene or resistant bacteria. Okay, that would be great. And the bacteriophage is something that I'm surprised. Okay, we went to the conference in the U.S. maybe early this year. Okay, and I'm surprised that most of the conference talk about therapy. Okay, have you ever heard about phage therapy? They use specific virus. Okay, that target bacteria specifically and make the preparation for the patient to eat in, and then that phage will go directly and bind with the resistant bacteria. Okay, at first it would be difficult getting live virus into patient's mouth. Okay, that's another step that you have to think about. You have to pass the ethic committee, human ethic, every ethic. Okay, and then you have to give patient that right fish and target at the right infection site. Okay, that's another story. But nowadays, I think this become more real. There's a lot of study of bacteriophage in Europe, actually. Okay, there's even a big company that produce fish itself. You can say that, oh, I want E. coli fish because one of my patients is resistant to all drug that we use, and he is in the final stage. He willing to try something new. Okay, so that happened nowadays. And also other PI or probiotic. Okay, that would be another way or alternative way for drug resistant bacteria. Okay, I think we have 1 minute here. I'm looking at the clock over there. I'll give the conclusion how to combat AMR. Okay, I put here the national policy because policy is important. Okay, if the guy doesn't think as the same as you think, so just drop that project. Okay, policy is very important. Education, you told me earlier, right? Education and awareness. Okay, and then you do surveillance, you do AMS program, good immunity, good vaccines coverage, and other good hygiene, and at the same time try to find new drug, new compound. I don't know either way from synthesis, from commercial, from in silico model, find it. And what we can do is don't let the antibiotic to be misused or used anyway. All right. So I think that would be it for me. This one is just for call to action. Okay. We have to think about it. If ourselves native get infected by AMR bacteria, none of drug work anymore. So what would you do? What would be the situation? Thinking about that would give you some pause before you use or prescribe the antibiotic. Okay. So I have to thank our group here. Okay. And it's also in this group, we AMRIC. Okay. Antimicrobial Resistant Interdisciplinary Center. We have this group working together with surveillance of the genomic genotype of the resistant bacteria and also finding the new way. We have some other group that work with phage therapy. Okay. And I also work with probiotics. Okay. Thank you so much. And if you have any question, I'm willing to take it.
Okay, so
Any questions?
at the first, ah, before that, let give a big applause for Dr. Malika for her presentation.
Thank you.
And maybe I will help with you if you want to have a questions, and I will translate it if you want to ask in Indonesia. And then I also get informed from Pak Fitra if there is a six for the person who give questions or also answer or just only questions, Pak Fitra.
I can ask the question.
Oh,
No,
I don't want to
kidding.
give
No, I'm
the
kidding.
questions. Oh,
Any questions?
oh, any questions first?
Or you can ask me, how
Uh-huh.
can I go for mobility in Bangkok?
Uh-huh. Pakai bahasa, it's okay.
Yes.
Okay.
Hey, my name is, and I want to ask why antibiotics can be bought without prescription in some countries. When this practice, like antibiotics without prescription, can increase microbial resistance, transmissions, and incomplete treatment.
You ask why?
Yeah, why? Why? A few countries can buy antibiotics without prescription when
Okay.
this practice can increase the resistance in
Yes.
Again.
It's very difficult question to answer. I have to say that since I was born in Thailand, we don't need prescription till now. Okay. So it's hard to implement something that much more complicated. If you say that, if you issue the law that, oh, from now on, land you need prescription for the antibiotic, people or everyone will say, no, 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 we've seen this all my life. Nobody will select you as the prime minister anymore. Okay, very complicated and related to the politics. So what's been done. But if you ask me what we can do, I think the pharmacist is the main key person or main have the major role to control it. Okay. You cannot say, oh, don't prescribe this drug. This drug is not reasonable. He just got viral infection while you give antibiotic. You cannot just go say that, right? But what you can do is maybe when you give the drug in the drugstore or you checking the drug in the hospital, you can check, you can aware that misuse or overuse can cause resistance. Okay. Let's start something small with yourself and then expand it to MS program, as I said. But again, I know besides your routine work, it will need much more energy to MS. It need collaboration, good relationship with nurse, with doctor, But I'm sure if you intend to do it, one day you can do it and make the role of pharmacist be stronger than today. Okay.
Okay. And then the next, okay, we've got the other one. Pak Pintar. Okay.
Okay, so hearing that the AMR is called by silent pandemic, what's the biggest challenge that faced by health expert um, for raising the public awareness about AMR? Next.
Hmm. So what you ask is how can we raise the awareness?
Yeah. So what is the biggest challenges that faced by health expert raising the awareness public of about AMR?
Actually, we have so many campaign. What's been done before is we have antibiotic day, antibiotic program that we can implement in, and there's other way that we can do. So maybe you tell me, you're a pharmacist in hospital, you want to give education and raise awareness, what would you do in the hospital? Yes. In the old day, in the hospital, when we do pharmacist, we will assign them to do this kind of program, like give education to patient, maybe education to nurse also, and do some campaign that the doctor can be involved with the infectious disease. So that's, I say, it's easiest way to do in the hospital. Okay, but otherwise it depends on the policy or the program or how strong you in the hospital. Very complicated question actually.
Thank you. And then the other ones, Ajan.
My name is Gege. I have two questions. First, from your perspective, what are the most important factor driving antimicrobial resistance in East Asia like ours? And second, what can students like us to do help prevent antimicrobial resistance? Thank you.
Because you asked me in Southeast Asia, I have to process my thought. Oh, Vietnam, Thailand, Laos, Indonesia. Actually, each country has own big uh, factor. Okay, as I said, some might say that agriculture would be the major problem if you think about the import-export rate for some country. Okay, or misuse or overuse, or Thailand would say, oh, we don't prescribe and we can buy antibiotic from any pharmacy shop. Okay, so I would say different factor.
Second, what can students like us to do help prevent antimicrobial resistance? Ini?
Here is this class or future pharmacist.
Yeah.
If you are a student, one thing that you do is in your family, is it reasonable to take antibiotic? Okay, because mostly when we get cold, some got like antibiotic, right? And cold caused by virus. some salt host caused by virus. So the rationale of antibiotic use, I think, is very important. Okay, it's similar to the awareness and education that we talked about it earlier. Okay, but as the pharmacist, okay, I answer of many of your colleagues here. We can start with our work, routine work. We have to check the right drug, right dose. Okay, the ADR, the drug interaction thing in the prescription that the doctor gives. So that would be start by yourself, and then you collaborate with Arthur, and hopefully one day do the AMS program.
Oh, the other one.
My name is Mayang. So I want to ask about material how AMR occurs. The question is it possible for intrinsic resistance to evolve into a acquired resistance over time, or this mechanism completely different?
The reason that I separate intrinsic with the acquired resistance, uh, if we know that bacteria A is resistant to this drug, we don't use it as. So I would say that it's not related to become acquired resistant, because at first, and we avoid this drug at first. So it's hard to get acquired resistant by this way. Okay.
Maybe still. Oh, okay. One question, student.
Excuse me, my name is Ki. Thank you very much for your helpful explanation. My English is not very good, but I try to ask. If a new antibiotic is discovered, what strategies can be implemented to ensure its effectiveness remains intact and does not quickly fade to resistance? Thank you.
Thank you. And I can understand you. So your English is good. Don't say that. Uh, your question remind me of the slide that I show. When the new antibiotic came out, later on, not more than 10 years, it become resistant. So it happened many, many times. You can remember that timeline in that slide, right? So you asked me how to do. I would say One Health policy, I would say AMS policy. If you implement it seriously, it can help prevent those problems. Okay? Can you do that, become pharmacist? Maybe stronger. Yes, stronger. Okay. Thank you so much for your question. It's nice to talk to you in this lecture. Besides,
And
because in online I cannot see your face, I cannot see your expression like today.
yes, and then there is still two questions, Ajahn Malika, in the Zoom. So I will read it for you because it's maybe small. Excuse me, Professor. My name is Willie. I would like to ask about Thailand's policy on controlling antibiotic resistance and whether it's been implemented in every region of Thailand. Thank you. But there's no questions mark, so it's the question is about the point, the Thailand's policy to controlling.
Yeah, actually we As a pharmacist, we set up the rational drug use policy. And I think that would help for people to be aware when they prescribe the antibiotic. So every time in the drugstore, we have pharmacists. In every drugstore, we have pharmacists. It's the law, actually. Not just only drugstore, not anyone can sell the drug, but must be pharmacist. Okay. And if you are a good pharmacist and you avoid this problem, I think that would be one thing that relieve the AMR problem. And I saw new or young pharmacists this day before they can give the maybe amoxicillin to patient, they just ask symptom, they just question them before prescribe. So I would say that we also adjust. It's not policy, but the awareness of the pharmacist itself that help with the AMR problem.
I think it's same here, Ajan, in Indonesia. So, and then the second questions, I would like from Yulia Rizky, Erli Satyati. I would like to ask about how to educate the public regarding the dangers of irrational antibiotic use. Where can we find and purchase antibiotics even in a small rural shops? That will be problem because in a some area, yeah, that will be need antibiotics too, but how to control it?
Actually, it's our job here for everyone, right? You will be a pharmacist one day, and it's your job to act as, oh, when you got prescription, you just take the drug as a prescription. You have to act more and educate people more. I think it's the direct role of pharmacists here. Okay, not just give the drug as the prescribed said. To think about the rational use, to have to think about the dose. Okay, and at the same time, you educate the patient. Okay, you consult them, you give information to them. One easy thing is you tell every patient, oh, please take antibiotic, take it all, even though you feel better. That sentence is, I never thought about this before until now, because that sentence is something that you can do. I think it's the basic thing that you can give awareness to the patient. Don't don't stop the antibiotic even though you feel better. You have to take the whole course of the antibiotic. That little thing you can do. Okay. They can expand your thought with other policy or other program. All right.
This is so important, and I think this is uh very good insight for you as second year of student, right? For learning about what's your responsibility by knowing how we can also prevent and also how to, yeah, avoid the bad things happen if we do not care about the antibiotic that we give to the patient better. Okay, so it is a good uh, topic for you for this class. And then is another Pak Fitra for the information. That's all.
Maybe I have last slide, guys,
Okay,
to
for
do.
the last slide. Okay, you can open the Mentimeter one more time.
Give me one word for the AMR lecture today. Let's see what it's gonna be.
The code is
Happy. We talk about serious problem in the world. You happy? What else?
the other. You can answer helpful, inspiring. Okay, more words. Impressive. What is Alex? That's the name. Who's Alex? Amazing. Insightful. Uh, Emoticon here. And then the other,
What is that, Sayang?
motivating. Uh, oh, this is an
What?
Thai words, Ajahn.
Tell me what in Thai.
And a big love.
That's it.
Saya suka. They say they love you, Ajahn Malik.
Oh, thank you so much. Nice.
Fun. Oh, there's one word, convincing. Um, okay. Cool. Informative, educative.
All right. So thank you so much. I also enjoy teaching you all here. And I hope one day I will see you in Bangkok. And one thing, so think about AMR a lot when you become pharmacist, taking a role of pharmacist and act as it. So that's all I want to say today. Thank you so much.
Okay, thank you, Ajahn. Oh, okay. Uh, Ajahn Malika, there is a handover souvenir from the head department. So there will be a session and over souvenir from Mr. Hatta Prabowo, PhD, as a head department, head study program of pharmacy, to give the souvenir for Dr. Malika. So that's all today. Okay, so thank you for coming for the lecture, the lecture today with an interesting topic, and thank you for your active participation, students. And we hope that we can meet again in the next few years. Okay, in class maybe together with Pak Fitra. Okay, so we can end with Hamdalah. Alhamdulillahirabbil alamin. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.